We will be using the Try It Online Occam emulator as usual. Here are the URLs for the base page for the Try It Online emulator. And here's the Try It Online emulator for the Occam Pi specifically that we're going to use. These are all in the description, so I would recommend that you copy and paste the description into a text file. There's a reference book that I mentioned several times, and here's the URL for that. We're going to look at some code, the Transputer Occam more procedures, which has call subroutine-like features. Also has some shared memory. We'll throw in a procedure and a function or so. So let's go ahead and take a look at this. So we have our main procedure, callme, and underneath that we define a couple of byte vectors, which are string characters for our purposes. We have an integer called length, a couple of real numbers, a mysterious thing called timer, clock, and now and delay. So let's go ahead and start looking at some code, print string procedure. Now this is a procedure, not a function. So for the first time, we're doing a procedure inside of a procedure. The val byte vector is the formal argument for a byte vector, which is an input. You can tell that by the val. And int size is a return value. So the return value isn't like a function where you assign something to it. You actually give it the name of this int variable that you want to put the return value in. So let's see how this works. So we give it a byte vector, or in our case, a string name, and it'll come in here and figure out what the size of that vector is. And then for 0 to size, for I equals 0, for size, it'll output each byte one by one, so until the whole size is out. So this is a pretty simple little procedure. But let's go ahead and take a look at it down here. So we're going to come down to here where it's used. String 1, which is what we defined above, we'll say is life is so peculiar. Then we'll print string 1 and return the length. We have this little function here that just outputs a carriage return. Then we'll outprint size equals, we'll output a space. And then we'll output our actual length. Now this is the value again, return from print string. So let's go ahead and run this. Wait for that to stop running. Okay, so there's our string, life is so peculiar, and it says size equals 19. And if we go back to the beginning where we defined it, string 1 had a length of 19. So that's all looking pretty good. But just in case you think we hardwired something into this little print string function, let's do a second string. So this time we'll print string 2, and everything else is exactly the same. So let's go down and see what happened. Did a Houdini, and the size equals 13. And in fact, string 2 was did a Houdini, and we defined it as having a size of 13. So that all worked out pretty well. Let's take a brief look at these functions we've done. One of the differences between a function and a procedure is functions are not supposed to have any side effects whatsoever. You pass in values, you pass out values, but nothing funny goes on, whereas procedures are allowed to have side effects. Basically, in this case, it sends a message out. So carriage return has no parameters. You send it nothing, you get nothing, but it outputs a carriage return and a new line and ends, which again is very convenient that if I want a new line, I can just say CRLF with no parameters and it'll do that. And I use this all the time, so this isn't a rig demo. This is something I actually want to use. Space is something I use fairly frequently too, so we had a little procedure for space as well. Okay, let's come down and take a look at our function. Remember, I started out with a function, which is not a procedure. It's a little different. That the input value is val int r, so this is the formal argument. We'll pass it in an integer, and it'll think that it's r, and then it'll return an integer. Result answer is an integer. So let's see what happens. We pass it an integer, and then the answer equals r plus 1, so it'll just increment it by 1. Result is an answer, which again is an integer. So let's see how this works. Okay, we're going to output a string 5 plus 2 equals, and then we're going to say the length equals +1 + 1 of 5. Now again, +1 was our function, so +1 of 5 is going to give you 6, and then +1 of 6 is going to give you 7, so it'll put a 7 in length. And again, that's again returned as kind of an argument to the function, so you have to actually put it in a variable. So we're going to output the length, and that's it. So again, let's go down and take a look at that. So we output our two strings, then 5 plus 2 equals, and there it is, 7. So our +1 function actually worked. As a matter of fact, our +1 function we actually used in kind of a recursive method because it actually called itself. Now, whether you want to call this recursion or not, I'm not going to get into an argument about software engineering. The last example is our, which is very, very important, even though it's very simple, is our total price procedure. So this whole thing has been set up so that we can come down here and call this function total price. This was kind of the whole point of this whole exercise was this. We want to see how this works. So it's a very, very simple function. Again, val is the input, so we're going to input a real number because again, you have a decimal point in dollars and cents of price, and then you're going to output total. So, val says input. If you don't have input, it's an output. So total equals price plus times 1 plus the sales rate, sales tax rate. Now, remember sales tax rate was something we defined way up here. It's a real 32. And that we actually gave it a value, the very, very close to the top of 0.04 or 4%. So we're going to come down here and say our cost is $987.65, say price equals, and then print the cost. Okay, we've already done this before, carriage return line feed. Tax equals just the cost times the sales tax rate. Again, nothing we haven't done before. We'll have a little bar we usually use for additions. Here's some mystery code if you want to see how clock works. That's a coming attraction. And then we get down to our total price procedure, where we pass it the cost and it passes us back the total cost. So we're output total price equals, and then we're going to output cost 2, which was the total cost, carriage return, and let's see if it did that. And so there's our $986.07.65. Our tax was $39.51. Our total cost was $1,027.16. And so yes, it did in fact return the total cost, but the really, really important thing is that the sales tax rate was not passed in as an argument, it was not passed in as a message, it was in shared memory. It was essentially a global variable. Some people don't like that word, so if you don't like the word, fine. But sales tax rate was defined up here, but it's in shared memory. Now, when you have two processes on separate computers, they don't have shared memory, so you can't have that. But when you have a procedure inside a procedure, obviously they are having shared memory, so you can do it. So this again is if you were jonesing for subroutine calls and shared memory or global variables, which is what I like to call them, then here's a way you can do it. Now let's kind of just remind ourselves of how procedures have worked up until this point. So let's go ahead and get rid of this. And this piece of code requires an input from the keyboard. So I'll type a character capital A. And let's, again, this is procedures. We've pretty much seen this before. I stripped out almost all the comments just so we can see the structure of what's going on. So we come in here, we declare a byte X. It's a channel of bytes. Sometimes you'll see channel of byte in some books. Sometimes you'll see channel byte. This particular simulator will allow either syntax. So that's just to kind of remind you that there are various arcane things running around. So we have our usual input channel, our output channel, and then we have channels between the procedures, comms1 and comms2. So in1, which is our keyboard, if you will, gets and assigns it to the byte X. So that's our capital A. Then comms1 outputs X, which is A. Now for every output, you have to have outputting a message, you have to have a corresponding input of a message. So here we go over to our other procedure where comms1 inputs an A. We increment the A by 1, getting a B. Then we output X. Here we get the X, and here we output it. So if we did this right, we should get B. Ta-da, we input an A, we output a B. Now, the way that these two processes know what each other are isn't because comms1 and comms1 are the same names. It's because of this procedure which ties them together, which I call communication. Again, we've seen this before. Input and output are kind of a special case. If you had like a microcontroller, an engine controller in a car, cars have dozens of processors, you're not going to have a keyboard and a screen, so this would just be a blank field. But comms1 and comms2 would very definitely be there if these processors are all talking to each other. So send it, this routine has an input and output. And notice this is comms1A, and this message is tied to this message and return it. So the way these two messages, we know these channels are the same, is this channel name is the same as this channel name, and this channel name is the same as this channel name. And that's what actually ties the channels together, is this little thing right here. So this is very, very important that we define these two procedures, but then we had to define how they're interconnected. So that's pretty much it. So that's a little more sophistication of what you can do with procedures. There's a whole lot more than just having inline code.